Hello, this is Sujit. Welcome to Physics 2020. So today I am going to start the next chapter, that is the second chapter in 11th Physics, motion in a plane. So previously we were discussing about the chapter that is motion in a straight line. In Physics 2020 there is a playlist called motion in a straight line. So in that playlist you can find all the videos. Both the conceptual videos and the problem solving videos of all the topics in the motion in a straight line, starting from displacement to the relative velocity in one dimension. So today I am going to start the next chapter, that is motion in a plane or motion in two dimension, that is starting with vectors. So vector algebra, that is vectors, plays a vital role in physics, very important topic. Because when we study physics, in physics there are two types of quantities, that is certain quantities have only magnitude and certain quantities have both magnitude and direction. So if you want to specify, that is mention the magnitude as well as direction of the quantities, we have to make use of, that is vectors. So that is the importance of vectors in physics. In the previous chapter, that is motion in a straight line, the quantities like displacement, velocity, acceleration, these quantities also vector quantities. But in one dimensional motion, that is only two directions are possible. Okay, so that is the motion in the rightward direction or leftward direction or upward direction or in the downward direction. Only two directions are possible in one dimensional motion. So we managed these quantities with the help of, that is positive and negative signs. So for managing the directions of these quantities, we used positive sign and negative signs for the direction. So but if you consider the motion of the objects in the plane, or in two dimension or in three dimension in the space, so we have to consider a large number of directions. Okay, in such situations we introduce another quantity, another physical quantity which is capable of storing both magnitude as well as direction, that is called vectors. Okay, so in this chapter we are going to discuss what is vector, what is scalar. Okay, what is the difference between vector and scalar? What are the characteristics of vectors? What are the types of vectors? Okay, so these are the things we are going to discuss in this chapter. So the second chapter, motion in a plane. Motion in a plane. So starting with vectors. Okay, vectors. So in physics, the physical quantities are mainly classified into two types. That is, one is scalars and another one is vectors. So the physical quantities are mainly classified into two types, that is scalars and vectors. So those quantities which have only magnitude, okay, only magnitude, no direction are called scalar quantities. So those quantities which have only magnitude and have no direction is called, that is scalar quantities. Example, that is mass, volume, okay, density, temperature, electric current. Okay, these are the examples for scalar quantities. So on the other hand, what is vector quantities? The physical quantities which have both magnitude and direction. Okay, both magnitude and direction are called vector quantities. Those quantities which have both magnitude and direction is called vector quantities. For example, that is a displacement, velocity, acceleration, momentum, etc. Okay, etc. So these quantities are called vector quantities. So vector and scalars in physics, the quantities are mainly classified into vectors and scalars. So scalar quantities means those quantities which have only magnitude, no direction is called scalar quantities, and the quantities which have both magnitude as well as direction is called vector quantities. Then what is the difference between vector and scalar? Okay, vector and scalar. So scalar, then vector. Scalar and vector. So scalar has only magnitude, no direction. Okay, so vectors has both magnitude and direction. Okay, first point. So second point, the scalar quantities change if the magnitude changes. Scalar quantities change if the magnitude changes. Okay, second point. So the vector quantities change either if magnitude, direction or both changes. Okay, so the vector quantities change if the magnitude changes or direction changes or both changes. Okay, then scalar quantities, third point, scalar quantities can be added using normal addition of ordinary algebra, using the laws of normal algebra, using the laws of ordinary algebra. Okay, scalar quantities can be added by the laws of normal or ordinary algebra. So the vector quantities can be added using the special laws of vector addition, using the special laws of vector addition. So using the special laws of vector addition. So these are the main differences of scalar and vector. So we have to make a study, that is differentiate scalars and vectors. So scalars have only magnitude and no direction. Vectors have both magnitude and direction. Second point, if the scalar changes, if the magnitude changes. Vector quantities changes if the magnitude changes or direction changes or both changes. Okay. Third one, scalars can be added using the laws of ordinary algebra. The vectors can be added using the special laws of vector addition. Okay, so this is the difference between, that is, vectors and scalars. Then next is representation of a vector. Representation of a vector. Representation of vectors. representation of vectors. So a vector can be represented by a straight line with the arrowhead. Okay, straight line with the arrowhead. So this is the representation of vectors. For example, force is a vector quantity. So we have to write that is F vector. Okay, acceleration is a vector quantity. So velocity is a vector quantity. Momentum is a vector quantity. So this is the way of representing the vectors. Okay, representing the vector. So a vector can be represented by a straight line with the arrowhead. Okay, arrowhead. So this is the representation of vectors. So the next is position and displacement vector. Position and displacement vector. In a coordinate system, so this is x and this is y. In a coordinate system, the position of the object is represented in terms of x distance and y distance. Okay, y distance. That is, suppose P is a object here. P is object. So we will, that is P of x comma y. Okay, x comma y. So where x and y are the distances in the x coordinate and y coordinate respectively. Okay, respectively. Then such a coordinate system is called, that is Cartesian coordinate system. Cartesian coordinate system. Okay, Cartesian coordinate system. So this is the origin. P is a object at a certain place. So that is the position of the object is represented by P of x comma y. So the position of the object is represented in terms of x and y coordinate distances. Okay, distances. Then such a coordinate system is called Cartesian coordinate system. So if a vector is drawn from the origin to the object, okay, if a vector is drawn from the origin to the object, then it is called position vector. Okay, that is position vector. Position vector. That vector drawn from the origin to the point is called position vector. So the position vector gives two information regarding the position of the object. The position vector gives two information. One is it gives the straight line distance. Okay, straight line distance of the object. Straight line distance of the object from the origin. From the origin. Okay. 2. It gives the direction of the object. It gives the direction of the object. Direction of the object. Okay, direction of the object. That is called position vector. So in a coordinate system, suppose the position of an object is represented in terms of x coordinate and y coordinate distances, then it is called a Cartesian coordinate system. In a Cartesian coordinate system, suppose if a vector is drawn from the origin to the point, then it is called, that vector is called position vector. So the position vector gives two information for the point. One is the straight line distance of the object from the origin. Then 2, it gives the direction of the object. Okay, direction of the object. That is called position vector. Then what is displacement vector? So the displacement vector in a Cartesian coordinate system, the displacement vector gives the distance and the direction in which the object has moved in a certain time interval. Okay, certain time interval. So the displacement vector gives the distance and direction in which the object has displaced. Object has displaced in a certain time interval. That is called the displacement vector. So again consider the Cartesian coordinate system. Okay, Cartesian coordinate system. So this is the origin. So this is x and this is y. Okay, y. So object that is P. So this is the position vector. Okay, position vector at time t. Okay, position vector towards the point at time t. So here that is another position of the object, that is we mentioned, that is p dash. Okay, p dash. So draw a position vector. Okay, draw a position vector. At the time t dash, that is position vector at the time t dash. Okay, t dash. So then the displacement vector is given, that is the time interval, that is t to t dash. The object has moved. The position, the displacement vector gives the direction and the distance of the object displaced in a time interval t to t dash. So this vector gives the displacement vector. Okay, displacement vector. Okay, so the displacement vector gives the direction and distance of the object moved in a certain time interval. So that is called displacement vector. So the next is polar and axial vectors. Polar and axial vectors. Polar and axial vectors. Polar and axial vectors. In a coordinate system, if the point is, or if the position of the object is represented in terms of the distance from the origin and the angle of inclination with the x-axis. Okay, angle of inclination with the x-axis. So this is the x-axis and this is the y-axis. So P is a point here. P is a point. P of r comma theta. Okay, r comma theta, where r is the distance of the object from the origin, and theta is the angle of inclination from the with the x-axis. Okay, x-axis. So like that. Okay, so theta is the angle of inclination with the x-axis and r is the distance of the object from the origin. Okay, r is the distance of the object from the origin. So if a vector that is in a coordinate system, if the position of the object is represented in terms of the distance from the origin and the theta, that is angle of inclination, then it is called polar coordinate system. Polar polar coordinate system. Okay, polar coordinate system. So what is polar vector? The vector for that point. So this object, if the vector is drawn from the origin to the point, then that vector is called polar vector. Okay, a vector which is represented with that is the distance from the origin and theta is the inclination with the x-axis. Then the vector drawn from the origin to the point is called polar vector. Okay, polar vector. Polar vector. Polar vector. Then what is axial vectors? Axial vectors. In a rotational motion, certain vectors will act through the axis of rotation. In a rotational motion, certain vectors will act through the axis of rotation. So this is the axis of rotation. Axis of rotation. Okay, axis of rotation. So in rotational motion, certain vectors will act through the axis of rotation. Okay, axis of rotation. So those vectors are called, that is, axial vectors. Axial vectors. So this axis of so certain vectors will act in the upward direction, or certain vectors will act in the downward direction. Okay, downward direction. So such vectors are called, that is, axial vectors. Okay, axial vectors. For example, angular velocity, torque, okay, torque, angular momentum, etc. Okay, so these vectors are called, these vectors are the examples for axial vectors. So axial vectors, in a rotational motion, certain vectors will act through the axis of rotation. Such vectors are called axial vectors. So the example for axial vectors are angular velocity, torque, and angular momentum. Okay, clear? So the next we are going to discuss the different types of vectors. Okay, different types of vectors. So one, equal vectors. Equal vectors. 2 negative vector, negative vectors. 3 modulus of a vector, modulus of a vector. Okay. Fourth one unit vector, unit vector. Fifth one fixed vector. Sixth one free vector, free vector. Seventh one collinear vectors, collinear vectors. Eighth one coplanar vectors, coplanar vectors. Ninth one co-initial vectors, co-initial vector. And the 10th one, that is coterminus vector, coterminus vector. So these are the different types of vectors we have to discuss. Okay, so we discuss one by one. First, equal vectors. Suppose if two vectors are said to be equal, means they must have equal magnitude and they must act in the same direction. Okay, suppose a vector and b vector. Okay, suppose if you want to say these two vectors are equal vectors, means they must have equal magnitude, that is mod a is equal to mod b, that is magnitude same, and they must act in the same direction, that is a vector and b vectors in the same direction. If these two conditions are satisfied, we can say that a vector and b vector are equal vectors. Okay, then second one negative vector. Negative vector. Suppose two vectors, a vector and b vector have the same magnitude and they are acting in the opposite direction. They have the same magnitude and they are acting in the opposite direction, means we can say that one vector is the negative of another vector and vice versa. Okay, a vector and b vector have the same magnitude, that is mod a is equal to mod b. Okay, mod b. They are in the opposite direction, a vector and b vector in the opposite direction. So then we can say that one vector is the negative of another vector, negative of another vector, and vice versa. Other we can say that if b vector is the negative of a vector. Okay, so that is the condition. So two vectors have the same magnitude and they are acting in the opposite direction, means we can say that they have the same magnitude and they are acting in the opposite direction. Then we can say that one vector is the negative of another vector and vice versa. Okay, vice versa. Then third one is modulus of a vector. Third one, that is modulus of a vector. Modulus of a vector. So a vector quantity that have both magnitude and direction. So if you consider the magnitude alone, okay, magnitude alone, so not considering the direction, then we can say that it is a modulus of a vector. Suppose a vector, a is a vector, okay, a is a vector. So the modulus of a vector is represented by like this, that is mod a. So which gives that's equal to a only, that is it gives the only the magnitude, not the direction. Okay, so the mod a is a what? Scalar quantity, scalar quantity. Okay, because it gives only the magnitude, not consider the direction. So that is called modulus of a vector. So understand that a vector is a vector quantity which have both magnitude and direction. So if we consider the direction alone, magnitude alone, then we can say that it is a modulus of a vector. Okay, so suppose a vector, so mod a is equal to, it give the magnitude only, so no direction. So it is a scalar quantity. Okay, scalar quantity. Then next is unit vector. Unit vector. Unit vector. Suppose a vector, A is a vector. If you draw a vector of unit magnitude, okay, if you draw a vector which has the unit magnitude in the direction of the A vector, then it is the vector of, that is unit vector. Okay, the vector which has a unit magnitude, that is called a unit vector. So that the direction of that vector is in the direction of A vector only. So which is represented by the A cap. So A is a vector. A cap is a unit vector that has the unit magnitude which is acting in the same direction of this vector. Okay, which vector? So every vector we can represent. So therefore we can write A vector is equal to, that is the modulus of A vector, that is magnitude. Am I right? Magnitude into A cap. So okay, so this gives the a modulus of A vector gives the magnitude, and this gives the direction. So because A cap is acting in the direction of the A vector. Okay, so we can write A vector is equal to mod A vector into A cap. So from this we can define the unit vector. So therefore A cap is equal to A vector divided by modulus of A vector. So this is the formula to find the unit vector of a vector. So unit vector is nothing but a vector which have the unit magnitude which is acting in the direction of a given vector. So suppose A vector which has the unit vector as a cap, it is represented by A cap. So therefore we can write A vector is equal to the magnitude, this is the magnitude, and A cap gives the direction. So therefore from this we can write A cap is equal to A vector divided by modulus of A vector. So this is the formula to find the unit vector. Okay? So then next is fixed vector. Fifth one is fixed vector. A vector which has a starting point as a fixed, okay, which a vector which whose that starting point is fixed only, then we can say that it is a fixed vector. A vector which has a starting point as a fixed one, then that vector is called fixed vector. For example, the position vector of a point, position vector of a object or point. So P vector, okay, P vector. So that the starting point of the position vector lies in the origin, or it is fixed with the origin. So that's why the position vector is an example for fixed vector. So what is the definition for fixed vector? Fixed vector means a vector whose initial point is fixed one. Such vector is called fixed vector. So all the position vectors of a point is an example. We can say that the position vector as a example for fixed vector, because the starting point of the position vector lies in the origin, or it is fixed with the origin. Okay. Then free vector. Next is free vector. So free vector is the opposite of fixed vector. Free vector. So whose initial point is not fixed. Is called free vector. So a vector whose initial point is not fixed means we can say that that vector is a free vector. An object moving in the velocity of the object moving in the straight line. So that is the example for free vector. So the acceleration of an object moving in the straight line. So we can say that it is a free vector. So that is a vector velocity. V vector is equal to, that is 5 meter per second. Okay, velocity 5 meter per second. So it is not fixed. Okay, the object is moving. So such that vector is an example for free vector. So velocity vector, acceleration vector, these vectors are the examples for free vector. Okay. Then next is seventh one, collinear vectors. Collinear vectors. Collinear vectors. If two vectors acting in the same line or acting parallel means we can say that two vectors are collinear vectors. If two vectors are acting in the same line or acting in parallel, then we can say that that two vectors are collinear vectors. So this one. Okay. So this is A and this is B. Or another example, that is they are acting parallel. This is A vector and this is B vector. Okay. So the angle between these two vectors, in both the cases the angle between the vectors theta is equal to 0. So they are called, if the angle between the two vectors is 0 means they are called parallel vectors. Parallel vectors. So collinear vector means, understand the definition, if the two vectors are acting in the same line or parallel means we can say that it is a collinear vectors. Okay, collinear vectors. So in another case, this is a case 1. In another case, suppose these two vectors, these also acting in the same line. So this is a vector and this is a B vector. Okay, they are acting in the opposite direction. So this is the case. So A vector and this is B vector. This is B vector. So in this case, the angle between the vector, that is angle between the two vectors, that is theta is equal to 180 degree. Am I right? Theta is equal to 180 degree. So this collinear vector is called anti-parallel vectors. Okay? Anti-parallel vectors. Anti-parallel vectors. So case 1 and this is case 2. So if the two vectors are acting in the same direction, or if the two vectors are acting in the acting parallelly, that is the angle between the two vectors is 0, that is theta is equal to 0. So that two vectors is called parallel vectors. If the two vectors are acting in the opposite direction, that is the angle between the vectors is 180 degrees. So in this case it is called anti-parallel vectors. Okay, then coplanar vectors. Eighth one, that is coplanar vectors. Coplanar vectors. If the vectors are acting in the same plane, if the vectors are acting in the same plane means we can say that coplanar vectors. Coplanar vectors. Suppose this is a plane. Okay, this is a plane. And these two are vectors. Okay, consider these two are vectors. So if these two vectors are acting in the same plane, you consider that, and this is a plane. Okay, so these two vectors are acting in the same plane. Am I right? Acting in the same plane. So this direction or this direction, anyway. So but these two are not in the same plane. Am I right? So this vector is in the plane, but this vector is not in the plane. So this is a coplanar vector. So this is a coplanar vector. This is a coplanar vector. But this is not a coplanar vector. If the vectors act on the plane, acting in the same plane means we can say that it is a coplanar vector. So, if the vectors act in the same plane means we can say that it is a coplanar vectors. Clear? Okay. Then ninth one, co-initial vectors. Co-initial vectors. If the vectors are acting from the same point, if more than one vectors acting from the same point, this is a point, three vectors, suppose A vector, B vector and C vector. Okay, C vector. So if these three vectors are acting from the same point, that is A, B and C. So this is A, this is B vector and this is C vector. So they are acting from the same point means we can say that these three vectors are co-initial vectors. Okay, co-initial vectors. Then coterminous vectors. If the terminal point of the vector is the same, if the initial point of the vector is the same, we can say that they are co-initial vectors. If the terminal point of the vectors are the same, okay, then it is called coterminous vectors. Coterminous vectors. Okay, so this is A vector and this is B vector and this is C vector. So the terminal point of the vector is the same. Then it is called coterminous vectors. Okay, so these are the basic definition or fundamental definition of different vectors. So equal vectors, if the two vectors have the same magnitude and the same direction, then it is called equal vectors. Negative vectors means if the two vectors have the same magnitude but they are in the opposite direction means a vector is the negative of another vector and vice versa. And the modulus of a vector, that is, the vector is a quantity which have both magnitude and direction. If you consider the direction magnitude alone, then it is called the modulus of a vector. Okay, it is a scalar quantity. Unit vector, that is a vector of unit magnitude drawn in the direction of a given vector, that is called a unit vector. The vector has a unit magnitude, unit vector. Fixed vector means if the initial point of the vector is fixed, then it is called fixed vector. For what is the example? That is, all the position vectors are examples for fixed vectors because their initial point is lies on the origin. Then we can say that it is a fixed vector. What is free vector? That is the opposite of fixed vector. If the initial point of the vector is not fixed means we can say that free vector. That is the velocity vector, acceleration vector are examples of free vectors. Then collinear vectors. That is, if the two vectors are acting in the same direction or acting in the same line, if they are in the same direction means the angle between the vector is theta is equal to 0, then we can say that it is a parallel vector. If they are acting in the opposite direction means the angle between the vectors is 180 degrees, so we can say that anti-parallel vectors. Okay? So coplanar vectors. If the vectors are acting in the same plane, means we can say that it is a coplanar vectors. Co-initial vectors, that is, if the starting point of the vector is the same, then we can say that co-initial vectors. And if the ending point or terminal point of the vectors are the same, then we can say that coterminous vectors. Clear? So the next is zero vector. Okay, zero vector or null vector. A vector which has a zero magnitude zero magnitude and they have the arbitrary direction is called zero vector or null vector. Arbitrary direction means the direction, unknown direction, okay, unknown direction. So therefore a vector which has a zero magnitude and has a that is arbitrary direction is called zero vector. So which is represented by zero vector. Okay. So what is the need of this zero vector? Suppose if a vector is equal to b vector, then what about a vector minus b vector? So that's equal to zero vector. That you have a zero magnitude and it has a arbitrary direction. Okay. So the properties of zero vector. So first property, a vector is added with a zero vector. So we will get the same vector. That is the first property. That is a vector, that is a vector, is added with a zero vector. So we will get the same vector, a vector. Okay. Second property, if the zero vector is multiplied by a real number, zero vector is, if the zero vector is multiplied by a real number, we will get that is zero vector. That is lambda into zero vector is equal to zero vector. Okay. Then third property, if a vector is multiplied by zero vector, if a vector is multiplied by zero vector, that is a vector into zero vector, so we will get zero vector. If a vector is multiplied by zero vector, we will get zero vector. Then fourth property, if lambda and mu are the two non-zero real numbers, if lambda and mu are the two non-zero real numbers, then we have the relation that is lambda a vector is equal to mu b vector. Okay, lambda a vector is equal to mu b vector if and only if. So this relation can hold if and only if a vector and b vector are zero vectors. Okay, zero vectors. If lambda and mu are the two non-zero real numbers, then the relation can hold. Which relation? That is lambda a vector is equal to mu b vector. We can write if and only if that is a vector and b vectors are zero vectors. Okay. So these are the properties of zero vectors. Then what are the physical examples of zero vectors? Physical examples of zero vectors. An object is lying at the origin. So an object is at somewhat this position. So what is the position vector? So an vector which is drawn from the origin to the object is called a position vector. Okay, position vector. Suppose the object lies at the origin. The object lies at the origin. So what about the position vector? Position vector is the zero vector. So we can say that the position vector of an object which lies at the origin is zero vector. Okay, zero vector. Then an object is stationary. What about the velocity? Velocity is zero. So what about the velocity vector? That is a zero vector. So we can say that the velocity vector of a stationary object. Okay, the velocity vector of a stationary object, v vector is equal to zero vector. Okay, an object is the next example. An object is moving with a constant velocity. What about the acceleration? Acceleration is equal to 0. So what about the acceleration vector? Acceleration vector is a zero vector. So an object moving with a constant velocity or uniform velocity, acceleration vector is equal to 0 vector. So these are the some of the examples, physical examples of 0 vector. So first example, the position vector of an object which lies at the origin is a 0 vector. The second one, the velocity of a stationary object is a 0 vector. Third example, the acceleration vector of an object which is moving with a constant velocity or uniform velocity is a 0 vector. Okay, so these are the some of the physical examples of 0 vector. So then the next topic is parallel shift of vectors. Parallel shift of vectors. Parallel shift of vectors. What is meant by parallel shift of vectors? Parallel shift of vectors means we can move the vectors from one place to another place without changing the direction and magnitude. That is called parallel shift of vectors. So the parallel shift of vectors means we can change the place of the vector from one place to another place without changing the direction and magnitude. That is called parallel shift of vectors. Suppose this is a vector, so that is F is equal to 10 Newton. So the same vector we can place also here. So without changing the direction and without changing the magnitude. So F is equal to 10 Newton. So the meaning is both the vectors are correct. Okay, so we are moving this vector from this place to this place without changing the magnitude and direction. This is a parallel shift of vectors. So this is a vector. So that is F is equal to 7 Newton. So the same vector we can place here. That is also parallel shift. So F is equal to 7 Newton. So parallel shift of vectors. This is a vector. So F is equal to some 5 Newton. So the same vector we can draw here. So that's also F is equal to 5 Newton means without changing the direction means this is the parallel shift of vectors. Okay. Then the next is angle between the vectors. Angle between the vectors. Angle between the vectors. So the angle between the vectors means the angle between two vectors means the angle between either head or tail. So the angle between the two heads we can consider as the angle between the vectors, or the angle between the two tails of the two vectors we can consider as the angle between the two vectors. So suppose this is a vector and this is also a vector. So the angle between the two vectors. So here one question arises that this is also the angle between the vectors. This also the angle between the vectors. So the total degree, that is, suppose this is theta. So what about this angle, that is the 360 minus theta. So the angle between the tails, whether this angle or this angle, that is the question. So always, that is very very important, that is angle between the vectors means always the smaller angle. Okay, smaller angle. Okay, smaller angle is the angle between the vectors. So this is the vector. So this is the angle between the vectors. Okay, so or otherwise the head, this is another vector, the head, that is also, that is theta. Okay, theta. So the angle between the tails or angle between the head. We can consider as the angle between the two vectors. Okay. What is the angle between the vectors? That is 90 degree. Okay, 90 degree. What is the angle between these two vectors? So, this is the angle between the vectors. No, this is wrong. Because angle between the vectors means the angle between two tails or two heads. Here, head and tail. So, this is the head of the first vector and this is the tail of the first vector. So, second vector. So, not this angle. So, how to find the angle between the vectors? So, parallel shift. Okay, we are shifting this vector. So, like this. So, we are making the parallel shift of the vectors. So, the same meaning only. Now, we can find the angle between the vectors. So, this is the angle between the vectors. Suppose this is 120 degree. Okay, 120 degree. So, what about this angle? That is the 60 degree. 60 degree. Clear? So, this vector and what is the angle between these two vectors? So, this is the angle between the vectors means the angle between the tail and angle between the two tails or two heads. So, here this is the head of the first vector, tail of the second vector. So, what we have to do? We have to make the parallel shift. So, this vector. Okay, now this is the angle between the vectors. Okay, suppose this is the 150 degree. 150 degree. What about the angle between the vectors? That is the 30 degree. So, clear? So, this is the way of finding the angle between the vectors. So, with this I wind up this session, the first section, that is introduction about vectors. Okay, so in the next section we are going to discuss the addition of vectors using triangle law of addition and parallelogram law of addition. Okay, stay tuned. Bye.